Hey everyone, today we're going to keep on practicing with solving inequalities, but today we're going to be looking at some special cases. And so this will probably sound familiar from when we were solving equations. There were instances where we could have either no solutions to an equation, or there could be all real numbers could be possible solutions. So we're going to have the same case here with inequalities, so we're going to look at how that looks with inequalities today. So let's look at our first example here. So my goal is to solve this inequality, and so we're going to use the steps that we've been using so far. Now the first thing I notice is there's parentheses here, and I know I can't do anything until those parentheses are gone. So I'm going to go ahead and distribute that 7 to both of the terms inside the parentheses. So when I do that, I know distributing is multiplication, so 7 times 2x gives me 14x. 7 times a negative 3 is going to give me a negative 21. Now I'm going to keep my inequality symbol the same. I've got 14x plus 5. So now my parentheses are gone, but now I notice I have variables on both sides of the equation. And I like to move my variables over to the left side. So I'm going to move this over by subtracting 14x from both sides. Now, when I do that, I have here 14 minus 14 is going to give me 0. I have 0 x's, so they cancel out, and I'm left with 5. Now, all I did was subtract here, so I haven't changed my symbol. Here, my x's cancel out as well, and I have a negative 21. So now, a couple things have happened. First, my variables have completely dropped out. So now I have to decide, is this a true comparison? Is 5 less than negative 21? Well, I know a positive number is never going to be less than a negative number, so I know this is not true. When that happens, when the resulting inequality is not true, we say we have no solution. That means there's no value of x that we could plug into our original inequality to make that a true statement. Now, let's look at this example here. I'm going to start off the same way. I notice I have parentheses, so the first thing before I even start solving, I have to simplify the right-hand side by distributing so I can get rid of those parentheses. So 6 times 2x is going to give me a 12x. 6 times a negative 1 gives me a negative 6. And now I can copy down the rest of my inequality. Just like before, I want all my variables on the left-hand side, so I'm going to subtract 12x from both sides. And maybe not surprisingly, we notice that we're going to drop out our variables on both sides. 12x minus 12x, my x's are gone. I'm left with negative 1 is greater than. Here my x's cancel, and I have negative 6. Now, it's probably trickier to compare. Here it was very easy comparing a positive to a negative, but sometimes people have trouble comparing when it's two negative numbers. So if it helps, you can always think about the number line. So I'm going to sketch one really quick. So I'm comparing negative 1, which is here, to negative 6. Now, in general, on a number line, numbers that are furthest to the right are going to be bigger than numbers that are very far left. You can also think of it as numbers that are closer to 0. If I'm talking about negative numbers, the numbers that are closest are the biggest. So in this case, negative 1 is greater than negative 6. This is true. So we would say that all real numbers are solutions. So we just write all real numbers to indicate that. All right, so we're just going to do a couple more examples to make sure we've got the mechanics of this, and then we'll use the last two as practice in class. All right, so our directions again say identify the number of solutions of an inequality, and we're going to write no solution or all real numbers if necessary, if we have a case like we did above. So for number 1, this time I'm noticing here my parentheses are on the left. I'm still going to distribute. So I have 5m plus 25 is less than 5m plus 17. I have variables on both sides. I want them all on the left side, so I'm going to subtract 5m from both sides. When I do that, these are going to cancel. I have 25. My inequality symbol stays the same. Here my m's cancel as well, and I have 25 is less than 17. I know that this is not a true statement, which tells me that, like case 1 up at the top, I have no solution. Well, let's see, for number 2, I notice I have parentheses here, so the first thing I need to do is distribute the negative 4. So a negative 4 times 2s gives me a negative 8s. A negative 4 times a negative 1 is a positive 4. Now here I want us to be really careful. We've said over and over again that if we multiply or divide by a negative, we need to flip that inequality symbol. However, that's only when I'm doing that to both sides. Here we were just multiplying on the right side, so my inequality symbol is going to stay the same. And I can copy it here. So now, again, I have variables on both sides. I want to move them over, so I'm going to add 8s on the right side, which means I need to do the same on the left. So now negative 8s plus 8s is going to give me 0s. That cancels, and I have 1. Less than or equal to, here my s's cancel as well, and I have 4. Obviously, we can look at that quickly. 1 is less than 4. This is a true statement. So we would say all real numbers are solutions of this inequality. And we just write all real numbers. All right. So that gives you a look at 2 special cases that we have when we're solving inequalities. The next 2 examples we'll use to warm up at the beginning of class tomorrow. So that is it for this video. Thanks!